All right, example 8. What's different about this problem is that all of my terms have the natural log in front of it. So this one's going to be done a little bit differently than the previous examples where we were rewriting them exponentially. But I still have to condense the two logs on the left together, and that's how I'm going to start the problem. So I have the natural log and then a fraction bar. Subtraction turns to division. It's the quotient rule. So 4x plus 6 goes on top, and x plus 5 goes on the bottom. And now I see that I have a natural log equal to a natural log. When you have two expressions on both sides with the same log and base, you are allowed to simply just remove the log, or in this case the natural log, and just leave the expressions behind to solve. It's the reverse of what we did before when we logged both sides. Now we're just going to be removing. And then I can go ahead and solve. And if you're not comfortable with just multiplying both sides by x plus 5, you can think of it like a proportion if that helps. I get x times x plus 5 is equal to 4x plus 6. And then I'm going to go ahead and distribute. And I see I have a quadratic, so I'm going to solve by factoring. It's not like every problem that you ever do that's quadratic, you're going to instantly solve by factoring. It's just for these log problems, that's typically what's going to happen and what's going to work. So when you're doing your homework, if you get a quadratic, move everything to one side and solve by factoring. So we have 5x minus 4x, which leaves you with x, and then subtract 6. And then this should factor nicely. And then we have x and 3 and 2. And to get a positive x on the inside, the 3 is going to be positive and the 2 is going to be negative. You get x is equal to negative 3 and x is equal to 2. And then we're going to go ahead and substitute in the check. So we have the natural log of 4 times negative 3 plus 6 minus the natural log of negative 3 plus 5 is equal to the natural log of negative 3. And this is the natural log of negative 12 plus 6 is negative 6 minus the natural log of 2 equals the natural log of negative 3. So I already have failed like multiple times over because you can't take the log or natural log of a negative number. So right there is a fail, and right there is a fail. And so negative 3 is an extraneous solution. And let's go ahead and check the 2. So we have the natural log of 4 times 2 plus 6 minus the natural log of 2 plus 5 equals the natural log of 2. So we have the natural log of 8 plus 6 is 14 minus the natural log of 7 equals the natural log of 2. And when you combine these two together, you get natural log of 14 over 7 is equal to the natural log of 2, and that's true. 14 divided by 7 is 2, and that one checks. So 2 is the answer, or is a solution. All right, let's do this guy right here. We have subtraction again. Okay, so subtraction turns to division. Subtraction is a quotient, or using the quotient rule. We have log base 2 and then a fraction bar right away. X plus 16 on top and x plus 7 on the bottom is equal to log base 2 of x. Now I have a log base 2 equal a log base 2 situation, which means I just get to drop that log base 2 and solve x plus 16 over x plus 7 is equal to x. And you can write it like a proportion if it helps. You don't have to. All right, so then we have x times x plus 7 is equal to x plus 16. X squared plus 7x is equal to x plus 16. Move everything to one side. You are going to get plus 6x minus 16 is equal to 0. Looks like our factors are going to be 8 and 2. So I have an x and an x and an 8 and a 2. Must multiply to negative 16 but add to positive 6. So that's how it's going to be sign-wise plus 8 minus 2. And then you get x equal to negative 8 and x is equal to 2. And then you have to go ahead and check. I already know that negative 8 is going to fail right away when I substitute back in just right here for x. So without even substituting in anything else, like instantly I can glance up and see that that negative 8 is going to fail in that last log right there. But you can go ahead and substitute it in a couple more spots and see that it actually fails in the second term as well. Negative 8 plus 7 is negative 1, and then you can't take the log of the negative there. So this one we can cross out right away. I still have to substitute the 2 in, so let's go ahead and check that answer. Oops. We have log base 2 of 2 plus 16 minus log base 2 of 2 plus 7 is equal to log base 2 of 2. And then I get log base 2 of 18 minus log base 2 of 9 is equal to log base 2 of 2. And then I have log base 2 of 18 over 9 equal to log base 2 of 2. And I can just stop there. I can already see that it's going to work. 18 divided by 9 is 2. And you get log base 2 of 2 equals log base 2 of 2. So that one checks. And then finally the last problem that we have right here is addition, and addition turns to multiplication. We're going to use the product rule. So I have log of x times x minus 5 is equal to log of 24. And because I have a log base 10 on both sides now, I can drop that log and just write x squared minus 5x is equal to 24. And then we have x squared minus 5x minus 24 is equal to 0. Factors of 24 that add to negative 5 are going to end up being, let's see, 8 and 3, and negative 8 and positive 3. So x will equal 8 and x will equal negative 3. And then I can see that if I plug a negative 3 in back into that first log to check my solution, that one's already going to fail because you can't take the log of a negative. And then you can just double check to make sure that 8 works. We have log of 8 plus log of 8 minus 5 equal to log of 24. And then we get log of 8 plus log of 3 equal to log of 24. And then if you turn your addition to multiplication, you get log of 8 times 3 equal to log of 24, and that works because 8 times 3 is 24, and you get log of 24 equal log of 24. So that checks, and 8 is a solution.